Hi everyone, good morning, good afternoon, wherever you are. Thank you so much for joining us for the second session of the DevSecOps Tech Talks. For those who missed the first session, Build a Multi-Cloud Secure Software Supply Chain by our expert speaker, David Curry. Please go on to the landing page or registration page. It is already available on demand for you to review that. But for this session, we have Pradeep Loganathan, who will be sharing a little bit more about how you can accelerate your path to secure production. So before I hand it over to Pradeep, I do want to say that if you do have any questions throughout this session, just pop them in the questions Q&A icon and section below at the bottom of your screen. There will be a live Q&A session just for Pradeep to share his answers to your questions at the end of this webinar. So go on ahead and do that. We'll also have some poll questions so we can have a little bit more engagement in this session. But that's about it. I'll hand it over to you, Pradeep, right now.
Thanks, Faye. Hey, everyone. Great to have you all over here. Before we get started, I'm really excited to share with you all that VMware Explore is coming to Singapore. The 2022 edition for APJ is at Singapore at the Marina Bay Sands Expo and Convention Center on the 15th and 16th. It's 2 days of some amazing conversation about multi-cloud, Kubernetes, application modernization, with lots of amazing speakers out there. I'm definitely being in Singapore, and I'm really looking forward to seeing you all over there. Please feel free to scan this QR code to register, and looking forward to seeing you all over there on the 15th and 16th of November. I'll just give a few more seconds for anybody who wants to scan the QR code and register. Okay. So we'll get started. Hello, everyone. Welcome to this conversation about accelerating your path to secure production in the DevSecOps series. As Faye said, the second conversation in the series. In the previous conversation, the amazing David Curry talked about building blocks to increase collaboration between dev, sec, and ops teams and continuously ship software securely with confidence. To get started, a bit about myself. My name is Pradeep Loganathan. I started my career at Logica, where I built the real-time gross settlement system for India. The last I checked, the system was doing around 15 million transactions a month. I also built retail and core banking systems for private banks in India. This was in the late 90s, and also one of the first mobile banking systems for the Middle East. This was the glorious era of the Motorola and the Nokia brick phones, and each page was less than 4 kilobytes in size. Post this, I joined Dell, where I was part of the team which built Dell's backend order management systems and financial systems globally, wherein we consolidated into a single global order management system. And I also was part of the team which built the global e-commerce systems from Dell.com to Premier.Dell.com to Solutions.Dell.com. Post this, I joined a UE, which is a mid-tier insurer in Queensland, where I built a cloud-based insurance platform from scratch. And then right now I work for VMware, where I do what I love the most, which is empowering developers and organizations using the VMware Tanzu suite of products. I'm also the founder organizer for Cloud Native Brisbane, which is an amazing meetup group with an amazing community around it, and also the founder organizer for the Sunshine Coast .NET user group, which is again another amazing community on the Sunshine Coast. Those are the endpoints at which I'm available. I'm available on Twitter, LinkedIn, and I also do have a blog. Please feel free to continue this conversation at any of those endpoints. I'm really happy to continue this conversation and look forward to hearing from you at any of these endpoints. So let's have a quick look at the agenda for today's conversation. Today, we're talking about innovating securely in the first section of this conversation. In the second section of this conversation, we'll be talking about supply chain vulnerabilities. The third part of this conversation, we'll be talking about innovating securely and stepping up to innovate securely. And the last part, we'll be talking about building secure supply chains, and we're looking at a demo of TAP, or Tanzu Application Platform, and how it can help you build secure supply chains. Before we get started, maybe we could just run a poll. Faye, would you please help launch the poll? We'd like to know and understand the audience better in terms of what role best describes you. So those are the options. We'll just wait for a few minutes for the audience to respond. Okay, looks like it's a mixed bag of people, which is pretty interesting, which means the content is much more tailored to a lot more. So I'll work through it. Thanks for your responses. As part of starting this conversation, in the first section, we'll understand how critical innovation is and how developer velocity is a key factor to innovation. In this internet and connected era, technology powers everything. All organizations ranging from retail to manufacturing to banking and finance, even cab aggregators, and everyone uses technology as a strategic differentiator. These organizations, in addition to mastering the nuances of the sectors that they are in, be it healthcare, be it banking, they also have to excel in developing and managing software ecosystems. A lot of organizations are not only working in the core business, but they're also being driven to excel in managing software ecosystems. Improving business performance through software development comes down to empowering developers and teams of developers and creating the right environment for them to innovate and also removing points of friction. This measure is generally known as Developer Velocity Index. It goes beyond the definition of velocity as it relates to agile methodologies. Generally, when we talk about this, people start relating it to agile methodologies in terms of story points, story velocity, etc. However, this is not the agile velocity methodology. Rather, Developer Velocity Index, it's not just about speed, but also about unleashing the full potential of development talent. A study by McKinsey across senior executives at almost 440 large enterprises highlighted that companies with a high developer velocity index score 55% higher on innovation. So this means in a lot of ways that higher developer velocity index leads to high levels of innovation. But what do higher levels of innovation actually means to business? And how does this focus on technology innovation relate to business success? This study by McKinsey also identifies that companies in the top quartile of the developer velocity index outperform the market by 4 to 5 times in terms of the compounded annual growth rate, or CAGR. These studies indicate a strong correlation between increasing your developer velocity index and business success purely in terms of enabling innovation to occur at a rapid pace rather than focusing on keeping the lights on. So basically what we're saying is that companies which have a higher developer velocity index, they outcompete their competitors, and they can definitely grow their top line by at least 4 to 5 times in terms of this study. But however, there is also a flip side to this rapid innovation. This drive forward to innovate and push boundaries must also be tempered with pragmatism and care. As organizations start to push forward in innovation, they must also focus on security. IBM conducted a study on the cost of data breaches for 2022, and this study indicates that 83% of the organizations that have had more than one data breach. Now, that's a pretty large number. And 45% of these data breaches were cloud-based. As organizations start to move to the cloud, a lot of these data breaches are occurring in the cloud environment. And another interesting number is that 19% of breaches occurred because of a compromise at a business partner. And this for me indicates the connected nature of business organizations now, wherein the primary business might be secure, but because a business partner was breached, the primary business was also breached. The average cost of a data breach was $4.35 million US. Now that's a pretty large number. And the average cost of a critical infrastructure data breach was $4.82 million or US dollars. Critical infrastructure organizations primarily work in critical infrastructure such as healthcare, banking and finance, telecommunications, and others. But the most significant number over here, or the most worrying number, at least for me, is the fact that it's taken on an average 277 days to identify and contain a data breach. Now, that's a pretty large number of days for the attackers to stay in the system, to move horizontally, to identify weak spots, to be able to exfiltrate data. And that's a very worrying number. The fact that somebody's had 277 days of dwell time to be within your system to exfiltrate data and to identify more weak spots. How do we then allow for innovation to happen securely? How do we ensure that our developers can continue to push boundaries and innovate, while at the same time they can be secure in the knowledge that the systems and processes that they work with will ensure that they're protected and safe? In this section, we will look at securing innovation by building secure supply chains. But before that, again, Faye will help us run a poll on the use of software supply chain to deliver software artifacts. Faye, if you can please help with the poll. Basically, what you're trying to see is how many of you out there use a software supply chain to deliver software artifacts. Thanks, Faye. Okay, the results are in. Looks like there's a pretty large number of people who do use a supply chain, but there are also some folks who are planning to, but a few others who are not very sure of the use of a supply chain. So in this section, we look at how innovation gets operationalized. As innovation gets built into processes and systems, they go through a build and delivery mechanism before it reaches the hands of its end users. This mechanism of delivering innovation to the end users is the software supply chain. All innovation goes through a build, test, and deliver phase through the supply chain. Security is generally added at the end of the run phase, where systems like VMware's Carbon Black provide endpoint security, container scanning, and a host of other functionality which secures your run environment. This ensures that the live system is protected and secured against malicious attacks and a lot of other issues. However, security cannot be an afterthought, only to be implemented in the run environment. Security aspects should be shifted left to be incorporated into your process as early as possible, so it can secure your software artifacts also as early as possible. This is a large impact as organizations work through app modernization programs involving cloud-native architectures. There are various challenges in shifting security left, especially in a cloud-native world. Most brownfield app modernization programs involve moving from monolithic architectures to cloud-native architectures. We also have greenfield systems where app modernization not only involves moving from monolithic system, but it also involves designing and building applications to be mobile first and cloud native. Cloud native architectures built on principles such as 12-factor apps, reactive design, and many others necessitate the creation of smaller microservices with REST API or gRPC or messaging-based endpoints. This also means that organizations now have many instances of supply chains and many more software artifacts to build, manage, and secure. Now, why is it critical to manage and secure a supply chain? Let us understand that by looking at the various vulnerabilities that can be exploited in a supply chain. And as in a supply chain, you can basically look at a supply chain in terms of source integrity and build integrity. And in terms of attack vectors and vulnerabilities, and many attack vectors possible. From a source integrity perspective, developers can submit bad code, either inadvertently or maliciously. Most of the times it is inadvertently, which might result in your source being impacted. Your source control can be compromised, which again means your source code is impacted. Your source code could be modified between your source control and a build platform, which again means your source is impacted. In a build integrity aspects, your build platform itself could be compromised, which means your builds are impacted. Your distribution packages can be compromised, which means your distribution packages are impacted, which also means that you're now deploying impacted packages to production, which are resulting in security issues. Your external package repository may be compromised, which means your build system is using bad dependencies, which again goes into a cycle of your builds being impacted and your distribution packages being impacted, and which ultimately results in your production system being impacted. So there's a lot of attack vectors and vulnerabilities that exist within a supply chain. And moreover, there are a couple of other things also that we need to think through. In a modern digital infrastructure, everyone is highly interdependent. Nobody lives in an isolated world. Every software artifact includes hundreds of dependencies, both direct and transitive. You might have your whole system behind a firewall. You might be working in an air-gapped system, but it still doesn't mean you're running in an isolated place. So no digital system is isolated. And for me, this XKCD cartoon lays it out much better than what I can even explain. And for me, the whole attack on the digital infrastructure and the supply chain is exemplified by two examples of supply chain attacks, one being Log4j and the other one being the SolarWinds Orion attack. We look at these two attacks, but I'll not go into the details because of limited time. Basically, for me, Log4j was an example of a supply chain attack, which really woke up a lot of organizations. I'm very sure a lot of us on this conversation have been impacted by Log4j. We have spent nights trying to resolve it, and we have spent many number of hours and weeks and weekends trying to ensure that our organizations are safe and protected. Log4j was pretty successful. It was a very small code change which resulted in a vulnerability, which impacted almost 17,000 Java packages in the Maven Central repository, which is one of the most significant Java package repositories. And this was then spread across a large number of organizations, resulting in almost everyone who had a Java software artifact running being impacted. The other example of a supply chain attack is the SolarWinds Orion attack. This is a much more larger, complex and sophisticated attack. This was a software tool for network and infrastructure monitoring. This attack was primarily on governmental organizations and large enterprises. Almost 18,000 organizations were impacted, and the attackers had nearly 18 months of dwell time, which means they had 18 months to run through the system, poke at defenses, try to understand how the system is organized, and exfiltrate data. A lot of data was also exfiltrated. And this again exposed the weaknesses of the supply chain massively. So now what we've done is we have seen how innovation is key and how supply chain enables innovation. We've also seen how, as part of pushing it for innovation, we need to ensure that we put in systems to ensure safety and security. We've also seen examples of supply chain attacks. And now let's look at how to help prevent these attacks. Before that, we'll again run another poll to see what sort of security frameworks do you use in your organization to protect your supply chain. Thanks, Wade. So the question is around, do you have a security framework for your supply chain artifacts? How do you secure your supply chain artifacts? Is there a process or a framework that you follow to secure your supply chain? We'll wait a couple more seconds for responses. And the responses are in. So we have a lot of people who have a framework, and I'm very happy to hear that. But we also have an equal number of people who are not sure of the security framework. And there are a few folks who have indicated that they do not currently have a security framework in place. Okay, so with these attacks on the software supply chain, and they've quite frequently been increasing. In fact, the attacks on software supply chain have increased many folds in the past couple of years. And the open source community have come together under the OpenSSF group to define a security framework to ensure better protection for the supply chain. This framework is called the SLSA framework, or Supply Chain Levels for Software Artifacts. This is a security framework and a common language for improving software security and supply chain integrity. The SLSA framework is focused on securing software artifacts from source through its deployment by allowing users to make automated decisions about the integrity of the artifacts that they're using, thereby preventing many possible attacks through the supply chain. It's an open source collaboration, and it's maintained as part of OpenSSF with pretty large contributions by Google, ChainGuard, VMware, CNCF, and many others. SLSA primarily defines 4 primary defensive measures. Again, in the interest of time, I will not be going into detail in each of these, but we'll just try to have a quick run through of these 4 defensive measures. The source defensive measure, or the source control category, recommends that source should be version controlled. Source code should have verified history. Source should be retained indefinitely, and every source should be at least reviewed by 2 people. Within the build control category, it recommends organizations to have scripted builds. It also recommends that build should be scripted as code, and that builds should be performed in an ephemeral environment. An ephemeral environment is a temporary environment which has been created just for that build alone and is destroyed post that build. So every build needs to be performed in an ephemeral environment. It also recommends that builds should be reproducible, which means that if your builds are scripted and if you are using code as a means of build orchestration, then your builds should easily be reproducible. It also recommends that builds should be hermetic. A hermetic system is a sealed build system which is not connected to the internet or which has no network access, and it's also immutable and declares everything immutably. The third control category is provenance. Provenance is the ability to identify and declare what your software artifacts contain and their dependencies and how they're layered. The provenance control category recommends that provenance should be available. That's the first part of it, which means that you can identify what packages exist within your software artifact. It then recommends that provenance should be authenticated. It also recommends that provenance should be service generated, which means it is generated automatically as part of build. Provenance should be non-falsifiable, which means that you should be able to attest that this provenance was generated and was not tampered with. And it also recommends that provenance should be dependencies complete, which means your provenance includes information not just about dependencies, the direct dependencies, but also about transitive and third-party dependencies. The fourth control category is common. The common control category recommends that security in the build environment is implemented. It also recommends that your build system's access controlled. It also recommends that super user access to your build platform is limited and regulated. Again, I'm not going into too much of detail into the control categories, which itself is a good half an hour session. But one area that I'm really interested in is the concept of provenance. SLSA has a pretty large set of recommendations, as I said, but if I would like to focus on provenance, provenance primarily includes information about what is contained in a particular software artifact and its history. In this case, the software artifact's provenance is provided by what is called as a software bill of material, or SBOM. And SBOM lists all software components within a software artifact. It lists the versions, and it also lists dependencies, which also includes transitive dependencies. And it also lists licensing information. So that's what's an SBOM. And SBOMs can be generated in various formats. There are tools out there to generate SBOMs. So there is SPDX, Cyclone DX, and SWID. Again, I'm not getting into the details, but one of the major formats that's being used, at least in my experience right now, is Cyclone DX, which is an SBOM format, which basically lists all the software packages within a software artifact, their dependencies, versions, and license information. So far, we have covered how innovation is key for an organization's success. We have covered how a supply chain enables innovation. We have looked at what the various vulnerabilities in the supply chain are, and we have looked at efforts to secure software artifacts and your supply chain, and also looked at various parts of that effort in terms of SLSA framework and how provenance and SBOMs are critical as part of this effort. We're now looking at TAP as part of this section. In this section, we'll look at Tanzu Application Platform and how it helps build secure supply chains. I'll also look at how it also comes along with a secure runtime and an amazing innovative developer platform. Tanzu Application Platform is an application development platform that provides a rich set of developer tools. It offers developers a paved path to production to build and deploy software quickly and securely on any compliant public cloud or on-premises Kubernetes cluster. It enables multi-cloud deployment scenarios, and which we will look at. TAP provides a superior developer experience and helps to increase developer velocity, which we talked about previously as to how key DVI is. TAP introduces the concepts of an inner loop and an outer loop. In the inner loop, the developer works in their local environment to develop code and test changes. The inner loop is a term that refers to the local, small, and iterative code changes that most developers make on a daily basis. A developer spends most of his time in the inner loop because it's fast and it gives instant feedback. As soon as the developer completes a cycle of the inner loop development and commits and pushes code to a source code repository, it triggers the outer development loop. The outer development loop is closely related to the CI/CD process. In the outer development loop, these smaller changes are packaged as a large commit or a feature branch and are pushed to a testing environment and eventually makes its way to production. Now we are focusing on the outer loop portion of the developer experience here. So over the next 4 minutes, we're going to dive into all of these components which make this possible, from Choreographer, which looks after the whole supply chain, to Flux CD for GitOps, using Tanzu build service and cloud native build packs for container builds, using security tools for scanning, signing, storing images and the metadata, and the convention service for customization, services toolkit, cloud native runtimes, which provide a container runtime using Knative, and it also provides auto scaling and scale to zero capabilities. Now, TAP has strong defaults, which enable a quick start right out of the box. Now, while strong defaults make it easy to get started with TAP, if one of VMware's choices of components in TAP does not work for you, the platform engineers or applications operations team can swap out these components based on an organization's requirements and preferences. In other words, you can substitute individual components easily through adapters. From CI tools to container build system, developers can use whatever they prefer as long as they are defined by the operations team. In this example, teams can swap out, for example, Tecton pipelines with Jenkins pipelines for running tests, or they can decide to swap out cloud native build packs with Kaniku to build container images. And there are many other such options. Now we'll take a quick look at the path to production. We'll see how TAP enables innovation and secure development practices in the inner loop. The inner loop was all about developer experience, and TAP shifts security left as early as possible in the development lifecycle. TAP uses Backstage to enable developer platforms. Now, Backstage is an open source project from Spotify, which has had a huge amount of traction in the open source world. Internal developer platforms enable faster developer onboarding and provide an amazing developer experience. It enables quick developer onboarding through Learning Center. It enables discoverability through software catalogs and API portals. Discoverability reduces the surface area of attack by reducing duplication and enables developers to be more productive. TAP provides application accelerators, which enable the creation of project templates for various programming languages. Now, these project templates incorporate an organization's security best practices and knowledge, and are authored by solution architects, enterprise architects, or security architects, and others within that particular organization. Accelerators provide a quick starting off on building microservices with all the security best practices built in. TAP enables developers to quickly iterate in the inner loop. Developers need not worry about Docker files or other aspects of the build process. They can quickly develop code and deploy containerized workloads. TAP also enables developers to monitor their workloads to help debug and resolve issues in various environments. It provides live view and is well integrated into IDEs like Visual Studio Code and IntelliJ. This helps developers to innovate quickly and securely in the inner loop. It also helps developers to focus on building business innovation, while the platform does a heavy lifting of building and deploying and debugging containerized workloads, while at the same time it shifts security left as early as possible. Now that we have seen the inner loop, let us also look at how TAP enables the outer loop and secures production flow. We'll look at how developers can focus on creating innovative solutions to deliver to end users, while the platform operator can design a pathway for innovation to flow securely to end users. I know that there's a lot of concepts. So again, as Faye said, please feel free to ask questions, even on chat if necessary. So please, if you have any questions, shoot it on chat and we'll definitely address it as we go along. So while looking at the outer loop as we're talking, as discussed in the development loop, in the development flow, developers can work on an interface that they're comfortable with, which is primarily Git. They could use either GitLab, GitHub, or any of the other Git providers out there. They check in code and create commits. Developers can create a workload that needs to be deployed. This workload is then picked up by the supply chain built in TAP, and the CI/CD pipeline is run. TAP uses GitOps to watch the Git repository. And once a commit is performed, the supply chain kicks in. The platform operator can use the out-of-the-box supply chain definitions to create the supply chain, or he can create a new definition based on their own opinions. The commit now progresses through the supply chain. TAP provides a codified path to production. TAP uses an open source project called Cartographer to choreograph the various Kubernetes resources through the supply chain. It uses another open source project called FluxCD to watch the Git repo for code changes. And once any code change occurs, that code change is pulled down. Tests are run using Tecton pipeline, which is again another open source project. Source code is scanned using Gripe, and the image can be built using Cloud Native Build Packs, which is again another open source project. The image is then pushed to the image which is now being built using Cloud Native Build Packs is then pushed to an image container repository, which could be either an in-house container repository built using some a technology like Harbor, or it could be any of the cloud container repositories like Azure Container Repository or others. This built image is then signed and attested. The image is then scanned for vulnerabilities and SBOM creation. A Kubernetes config is created to indicate the generation of this image and its associated container repository. GitOps operators running on the testing environment can now pull this image and deploy it onto the testing cluster, or the UAT cluster in this case. Once all tests are completed, the developer can then update the config to indicate that this can be pushed to production. Then the GitOps operator running on the production cluster will now pull this container image and deploy it and make it available to the end users. So we've run through a whole process of supply chain, and we have also at the same time taken care to shift security left as early as possible. We've now seen how TAP enables shifting security to the left as part of the development flow and also as part of the production flow. Even though it's a pretty large area, the specific areas where TAP lays out a larger emphasis on securing software artifacts are scanning the source code and scanning the image using open source tools like Gripe, Sneak, and others. It generates provenance and creates an SBOM in a variety of formats. It also signs artifacts cryptographically using cosign, and it also stores by metadata. It provides a centralized location to store dependency and vulnerability metadata, which is also called as metadata store. The other primary area is TAP provides GitOps right out of the box. GitOps is currently implemented using FluxCD, which is again another open source program. GitOps enables organizations to version control deployments as well as code. All configuration is in Git, meaning everything is traceable and repeatable. And this ticks most of the SLSA boxes that we previously talked about in terms of two people or two persons verifying all code, auditability, traceability, using source control, managing version history, and many others. This also eliminates tribal knowledge that gets built within organizations and automates processes, and it allows for best practices to be baked in. With that, we'll also be looking at, as part of the demo, we'll be looking at how TAP implements GitOps. Over here, I got a screen grab of a GitOps process within TAP, wherein we've had a couple of approvals to deploy a workload to 2 different delivery clusters. Now, TAP can be deployed in a multi-cloud environment across Azure, GCP, and EKS as an example, and you could have each of these clusters pulling code or pulling container images and deploying them independently using GitOps. TAP will also be looking at application accelerators, which, as I previously talked about, is a template for secure source code, which can be built by architects within the organization. And as part of the demo, we'll also be looking at image scanning. Over here, as part of the screen grab, I'm showing an image scan being performed, or rather a source scan being performed using grep, and an image scan being performed using Sneak. So with that, we'll sort of jump into the demo. And as it's a live demo, it's very much possible that things can go horribly wrong, but let's give it a shot. I'll just get started and share my screen again. Hey, can you see the screen?
Yeah, it looks
Thanks.
good.
Thanks. Okay, so what I've also done as part of the demo is I have a TAP instance running, and I've also created a small Markdown document, which I've shared on GitHub. And what we'll be doing is to look at the instance of TAP. So this is Tanzu Application Platform. And as we talked about, one of the first things that TAP allows is for discoverability. So if I put on, what I've done is I installed TAP late in the evening yesterday. And as part of installing TAP, there are 2 items that I specifically configured. If I put my platform operator hat on, and if you are a platform operator, the 2 primary, this is an out-of-the-box implementation of TAP. I've only configured or customized 2 areas. One is I've created a Tecton pipeline. This Tecton pipeline is necessary for me to be able to run tests on my workload, which I'll be deploying as part of the demo now. So I've created this Tecton pipeline, and the other change that or rather the other configuration that I've done is a scan policy. I'm using grep to perform both a source scan and an image scan. And for me, this is very important. TAP allows you to indicate what's the security posture that you would like to adopt for your workloads. In this case, I've said I want security posture which does not allow any workloads which have a critical CVE to be deployed through my pipeline. So the pipeline will definitely block any workload which is a CVE marked as critical. However, I also want to add another flavor to it, wherein I wanted to show that you can still ignore certain CVEs. So I have specifically ignored certain CVEs. I know for sure that this particular CVE is a high critical severity, but I still want to show how you can configure the scan policy to be pretty fine-grained. It took me quite some amount of effort to ensure that I can come up with a demo which allows me to show critical CVE and how I can ignore a critical CVE and how I can allow other workloads to progress through with the necessary scan policy in place. So that's what a platform operator can work on. And this is a very, very limited set of configuration that I have done, wherein I've said it's a single cluster deployment on GCP. So the 2 areas that are primarily configured is a Tecton pipeline and a scan policy. So if I now put on my developer hat on, and let's assume I join this organization and I'm part of the customer management team, and I'm interested in creating an API which my a program manager or tech lead has asked me to work through, and I'm trying to understand better about what software artifacts or what software components my team has. So this is the software catalog wherein the developer can go in and figure out what components exist within this particular team or within this organization. And there is a lot of options to filter, tag components. So over here, as a developer, I can come in and see that there is a customer cache component. I can see that there is a customer rating database. I can, in fact, go in and view source For example, if I want to view the source of the customer cache system, I can go in and view source code. I can look at tech docs. If this was an API, I can look at the Open API specification for this particular API, and it allows for rich metadata in order to be able to allow for discoverability. So this is the catalog. And for me, catalog is important from a security context, purely because in my experience, the lack of discoverability ensures that there is a huge amount of duplication, and that duplication results in a larger surface area of attack. So the catalog is pretty critical, and the reason why the catalog is within TAP is also primarily because if you really think about it, the build system is where your software artifacts get created. And this is where all software artifacts pass through as they are being born. And this is an ideal place for these components to be listed and for these components and their metadata to be captured. Post this, there's also documentation. As I said, there is learning center and a lot of other areas where developers can come in and know and understand the software ecosystem that they're working in, the components that they already have, and what sort of functionality already exists. And this is an application starter. So as I previously told you, an application starter allows for a quick start for developers. A lot of organizations currently have metrics around how quickly does a new joinee perform a pull request, or how quickly or how much of time before a new joinee or a new developer can push code to production. And these are pretty good metrics which measure how somebody could be onboarded quickly or how well the process within an organization works. So the App Accelerator provides a software code template for somebody to get started. So in my case, as I put on my developer hat, and let's assume I've been asked to create a weather forecasting API for my system. So I can go over here and see that there is already an accelerator. I can explore the accelerator even more. So this is the accelerator. I can look at the code that the accelerator provides. I can this template can sort of incorporate all the OWASP top 10 best practices as an example. So let's assume I do a weather forecast API, and this is the API that I want to create. I generate the accelerator. I can browse through the accelerator. I can see the initial templatized code that the accelerator generated for me. I can see what packages it pulls through as an example. And yeah, I can then download the zip file and I can get started on developing this piece of code. So that's on App Accelerators. Let's also quickly look at a pipeline. So this was a workload that I pushed through the pipeline today morning, or rather late in the evening yesterday. So you can see that this particular pipeline has pulled source code from a Git repository. It has run through tests through the Tecton pipeline that I showed to you previously. It scanned the source code. It's built the image using Cloud Native Webpacks. Then the image was scanned, and these are all the CVEs that were identified within this particular image. You can see that there are quite a few CVEs, around 49 CVEs, but you can also see there are no critical CVEs because we had a scan policy which indicated that our security posture was okay with anything which is not critical. So even though I know that I had to figure out an image which did not have critical CVE. So this lists the CVEs. Then we have, as we go through the supply chain, we can also see then that the configurator did push the image into a repository, into a container repository, and updated Git and post that using GitOps. Since I'm running a single cluster setup, it was pulled down and delivered into my cluster. What we'll do right now is we'll run through on creating a supply chain. Again, as I put my developer hat on, so I've downloaded my application accelerator. I'm developing a weather forecasting API. I've made the necessary changes to my code, and I've also pushed it to Git. And let's assume this is my weather project where I, as a newcomer, came in and created a weather forecasting API. And this weather forecasting API provides weather forecasting for 7 days, let's assume, right? So right now, as part of delivering this to production, as I said, as a developer, I create a workload. So I can create a workload using Tanzu. Let me also use the notepad so that, okay. So I can create it using Tanzu apps workload create. So app also has an amazing CLI, and this CLI allows a lot more exhaustive workloads to run through. So basically what I'm doing over here is to create a workload, and this workload is the weather forecast workload that we talked about, and it points to a Git repo, and basically we're deploying this code in a namespace called application namespace. And what we're also doing is we're saying that we'll be using an out-of-the-box supply chain, which will run through testing, scanning, and deploy it into the cluster. So right now I'm creating a workload. If you realize the developer did not create any YAML files, he just worked on his code and through Git, and there is no YAML being written by the developer at any point in time. So I want to go ahead and create this workload, and the workload has been created. And TAP also helpfully offers to say, hey, I mean, you can review what's happening. So while we review what's happening, what I'll also do is I'll show you what's happening on the background. So we can see that the workload has been pulled in over here. We can see that on the cluster, the pipeline has started to run through. I can go over here and check what's happening over here. So we can see the pipeline has been created, source has been pulled down, and tests are currently being run, which is what is being indicated in the log output over here. And if I look over here, scan was just complete. So you can see that source scan was complete because it's a small application. There's not many issues in the source code. Build is currently started, and you can see that build is currently in progress. And I can see something very similar over here, wherein it indicates that source code scan was complete, and the results of the source code scan were updated into the metadata store. So right now, build has started, which I can see the build pod has started to run. You can see the output over here. Since it's a .NET application, we're using Cloud Native Build Packs, it automatically identified that it was a .NET workload and it started to build the application. And you can also see it visually being represented in the TAP GUI. So we can see here that these steps have been complete. We can see that source code was pulled down, tests were run using the Tecton pipeline, source was scanned using gripe. There were no issues which were found, and currently build is running, which is what we can see over here. So Cloud Native Build Pack has successfully built, and it's right now creating the necessary layers of our image. And it's again adding information into the metadata store to indicate the SBOM, the BOM that was created as part of the build. We'll just give it a couple more seconds to complete. I'm not running on a very large cluster. I'm running on a very medium-sized cluster with 4 CPUs and 16 gigs of memory. Okay, scan is complete. We'll look at where we are right now. It's still being updated into the metadata store. We'll look at the GUI to see what does the GUI indicate. The GUI indicates that image build is complete, and the next step is image scan, which is starting right now. Which is what the output indicates. So image scan is complete. Config provider is also complete. Config writer is complete. So right now we have successfully built the image, scanned it, and right now it's being pulled into the production cluster. We do have information about the scanning output. You can see that the scanner did identify around 40 CVEs. And again, most of these are in the low and medium category. We'll just wait for a couple of seconds before the application gets pulled. And while that's happening, okay, so the production cluster has successfully pulled the image that was generated. and is right now deploying it into the cluster. It's basically using cloud native runtimes, which provides you a container runtime environment, which provides scale to 0. We'll just give it a couple more seconds to deploy it. We can at the same time look at what's happening over here. We can see that the deployment has started to run. The queue proxy and workload are here, which means the runtime is up and running. So which means workload has been successfully deployed, which we can see over here. Now to get the status of, or rather to get the endpoint of the workload, what I'll do is I'll do get case we see. So this is the workload that we deployed. We have an endpoint right now. So what I'll do is I will, since I've generated a weather forecasting application, I will curl the endpoint. And yep, so there we have. So what we have right now done in this short span of 15 minutes is to create a workload and run it through a pipeline. We've defined a pipeline, we run it through a pipeline, and as part of the pipeline, we ran through this whole process. We used GitOps to pull down source code. We then ran it through tests using the Tecton pipeline. We scanned the source code to ensure that there are no issues, no security issues with the source code using Gripe. We then created an image using Cloud Native Build Packs. We scanned it using Gripe. We also added the necessary conventions, and we used Config Writer to create an entry into the container registry and the Git repo. And then we use GitOps to pull it into the production cluster and deliver it. And we have it running over here. So this for me represents the power of TAP, the ability to quickly take a workload through the whole process. TAP also provides an amazing security features using Tanzu Insights. So for example, if I want to know and understand insights about the source in terms of the packages that it contains, I can see, for example, this was a Java application that I was looking at. If I look at this particular Java application over here, I can see that the commit over here is 6 dB, which is what I'm looking at over here. And I can see that this Java application has 4 different packages. Primarily it's a Spring Boot application. So it's a Spring Test, Spring Web, and the actuators and the dev tools. So these tools give me insight into what packages the source code contains. I can also look at the packages within an image and not just the source code. For example, over here, I'm using Tanzu Insight packages to say what packages does this particular image contain. Basically, I'm looking at the image built over here, which is the E2A6 image. And if I see over here, so I'm trying to see, so this is a huge amount of output. So this is basically, it gives me insight around the packages that the image contains. And I'm only limiting it to 10. But if I really want to know and understand about every package, which is generally not something that you, I'm sorry about that, that you would do. So this produces a huge amount of information about all the packages contained within that image. Now, if I want to flip it and understand about all the vulnerabilities that the image contains and the packages which contain those vulnerabilities, I can also do this. So over here, what I'm doing is I'm asking for vulnerabilities contained within this image. So you can see that there is a vulnerability, which is CVE 2022-42003, and it's contained within these images, especially around Jackson data bind. So I can list out vulnerabilities and all the packages that contain that particular vulnerability. So, and let's assume I'm interested in a particular vulnerability, I can do even that. So for example, if I'm interested in this high critical vulnerability, and I want to identify if there are any packages that contain this high critical vulnerability, I can do that. So for example, this particular vulnerability is contained by the Spring Core package. This is very similar to what would happen in case of certain supply chain attacks, wherein a particular package might be impacted, and you want to identify all software artifacts in your supply chain which contain that particular vulnerability. So Tanzu TAP also provides a lot more functionality in terms of identifying vulnerabilities, in terms of identifying packages within your images, in terms of generating SBOMs, and a bunch of other functionality. And it's pretty powerful in that way because it can integrate, you can create this, use the CLI tools to integrate with other tools too. So this for me represents running through the supply chain. I'll just pause for a few minutes for questions. And this for me is a supply chain that we ran through. So that's TAP, wherein we created a complete supply chain. We deployed a workload through it, and we ran through and created a container image and deployed it to a cluster. Let me stop sharing and reshare my screen. So please feel free to try out TAP. As we saw, TAP makes it easy to generate pipelines. It makes it it gives a bunch of out-of-the-box supply chains for you to use to make it easy to deliver software to various environments. And it's also something that can be highly customized based on your organization's needs. And it also works in terms of shifting security to the left as early as possible. Thank you for your time. I'm happy to take any questions. Faye?
Thanks, Freddie. We did get a lot of questions from the floor. So thank you so much for all your questions. And if you still have any, just pop them in the Q&A portion at the bottom of the screen. We'll try to get them answered now with Freddie, or we will reply you with an email answer in the next couple of working days. So Pradeep, the first question that I got is, how can an organization get started on implementing SLSA? Are there guidelines to get started?
Yeah, that's a good question. SLSA is a pretty large, comprehensive framework. It's very hard for organizations to say, I will go about implementing the whole of SLSA in one single iteration. And that's the reason why SLSA provides multiple levels. So there are 4 different SLSA levels, with each level progressively building on the previous level. And the first level makes it very simple and easy to get started, wherein it's much more about ensuring that there is source control implemented, that you have certain basic levels of security practices built in. And then there are level 2, level 3, and level 4, which constantly build on top of these practices and make it repeatable and make it easier for an organization to get started, while at the same time helping them with a pathway in terms of building on top of their security practices. We could maybe do a longer session at a later point in time with more about implementing all the various levels of SLSA and how TAP can help with all these various levels of SLSA frameworks. Thanks for the question.
Okay, thanks, Pradeep. Couple of other questions. So earlier you did talk about signing.
Yeah.
How does signing work in TAP?
So TAP, I did not demonstrate signing as part of the supply chain because I had not set up the signing component completely. And that for me represents the power of TAP in terms of organizations specifying the level of maturity they are in, wherein they can say, hey, we are not at a level of maturity wherein we want to sign our software artifacts, so they can take it out of the supply chain. But if organizations build up on the maturity level and they can say, we are right now in a position where we can add signing into the supply chain, they can add it. So in terms of signing, what generally happens is that you use a private key infrastructure to sign all the container images that you produce, and your cluster would only run container images which have been signed. And we can further build on top of it using attestations, where we can attest images and ensure that we could do maybe a gatekeeper policy, which ensures that only images which have been signed by your organization can run your cluster. And that's a huge amount of security for a software artifact, because it ensures that only images that you know and understand can be deployed within your cluster.
All right, thanks, Pradeep. I'm just going off video because my internet connection isn't that great. So maybe one last question for you. Can TAP work in air-gapped scenarios? That's
a really great question. A lot of organizations that I've worked with have requirements for air-gapped environments, specifically financial sector, banking, and maybe even sometimes healthcare sectors too. So TAP definitely works in air-gapped environments. We do have specific ways to get TAP deployed in air-gapped environments, and the whole functionality completely works in air-gapped environments. There are certain requirements around, for example, vulnerability database. Vulnerabilities are very dynamic in nature, and vulnerability databases get updated on an hourly basis. So things like vulnerability databases, as an example, is something that needs to be available internally to the organization to enable TAP to work in an air-gapped environment. But TAP definitely works in an air-gapped environment, but there are certain other steps which needs to be taken in order to enable TAP to work in an air-gapped environment. But yeah, that's a great question.
Okay, thanks so much, Pradeep. I think we have enough time for those 3 questions. Maybe we can close out the session.
Cool. So thanks everyone for your time. I know this is a lot of information in a very short span of time, but as I said, please feel free to reach out at any of those endpoints that I previously listed. This is a second of the series of seminars that we are doing of the 3-part series. The first one was David Curry. This is the second one, and third one is being done by my dear colleague, Paul. He'll be talking about developing a modern security strategy for modern applications. I would strongly encourage you all to attend that session. Please do scan this QR code to register for this session. This follows and builds upon what we have been talking so far. And that session is primarily focused on security strategy for running applications. And I'll be there, and I'm really looking forward to joining you all as part of this session.
All right. Thanks, Freddie. So we'll keep this on for a couple of minutes on the screen. Just to share, right after this webinar, we'll try to get this recording loaded up, and then you'll be able to, review all the good stuff that Freddie shared earlier. There
is another question. The question is, does TAP integrate with Carbon Black container security? TAP definitely does integrate with Carbon Black container security. Carbon Black scanning, as I showed, there is container scanning available. And also source code scanning available. So Carbon Black, we use Carbon Black's image scan functionality, but that is currently in beta and it will be released soon. But we do definitely use Carbon Black as one of the options from an image scan perspective.
Sounds good.
Sorry about that.
No worries. Yeah, if anybody has any more questions, please pop them in. We'll just leave this on for a little bit, and then see you guys the next time, or if we do get another question in the next minute. I've also popped in the link to the DevSecOps Tech Talk series, where you can register for the next session or look back and review this session when the recording is posted on demand in the next couple of working days. So we'll just stay on for a little bit and then close this out. Thank you everyone for your time. See you really soon.
Okay, thanks everyone. Thanks, Faye.
Okay, we'll just close this out now. Have a good day, everybody. Thank you so much for joining.
Thank you.
Bye.